So good morning and welcome to the IperionX Limited Investor Webinar. My name is Jane Morgan. I'm the Investor and Media Relations Manager. And today I am joined by our Managing Director and CEO, Taso Arima. Today we'll be running through an investor presentation followed by a Q&A session. So to ask a question throughout today's presentation, please use the Q&A function, which can be found at the bottom of your screen. Taso, I'll hand over to you.
Thanks very much, Jane. And thanks everyone for joining again. Like Jane said, we've released an updated presentation to market, and so I wanted to hold this webinar to take people through the story. Since our last webinar, we've made a lot of progress across our business, and I think we've laid out here what we are currently planning to do, and I think it explains very well how we approach the titanium supply chain, how we're going to be a big player in the titanium supply chain, and the opportunity for building what will be a very substantial business in reshoring titanium metal manufacturing in the United States. So what we do, as everyone knows, we are focused on reshoring titanium metal manufacturing in the United States, but we're focused on not just reshoring it, but doing it at a high performance level and doing it at lower cost using our proprietary technologies. So we have already signed, as many of you that have been following us have seen, we've signed some major customer partnerships, recently GKN Aerospace, prior to that Lockheed Martin, Ford Motor Company, but we already also have titanium metal products already out in the market. And here I'm showing the Panerai, which is part of the Richemont Group, one of the largest luxury groups globally, that also has brands like Cartier, Van Cleef, and RWC. This is one of the first products that has come to market middle of the year with our titanium metal in it. They call it eTitanio. This is a luxury watch application that needs to perform at the highest levels and also needs to look have a very good finish and look as well. And so it just goes to show that we've already got product out there. We've got customers that love our product, and we are increasingly getting into the market with our titanium metal. So we produce high performance, low cost titanium metal products, and we're already doing it today. So the business, our plan to scale the business has not changed. It is starting again on titanium metal scrap, where since the last webinar, we have secured significant scrap supplies. We start on titanium metal scrap, where our proprietary technologies allow us to take either scrap or mineral and process into titanium metal. So we start on scrap, develop a 100% circular supply chain of titanium metal. There's a lot of excess scrap in the market, as people can see from the amount of scrap that we've been able to secure. And then we backward integrate over the medium term to long term with the titanium mineral operation. And that is our Titan project, which recently, since the last webinar as well, we've had it go through permitting, and now it's fully permitted and ready to be developed when we want to. And this is the largest source of titanium minerals in the US. It's got a good product, co-product of rare earth minerals as well. And we have had significant strategic interest, as we announced a month ago, from Japanese parties in the end products as well from the Titan project. So the business strategy to drive forward has not changed. We're starting on scrap, starting a circular supply chain of titanium metal, and that is from today and scaling over the next few years. And then over the medium term, say over the next 3 to 5 years and over the next decade, we're incorporating and backward integrating those titanium minerals into the production of our titanium metal products. So the reason, one of the big focuses of titanium metal and reason people like it is that it's got superior properties. As we can see, from defense through to consumer electronics, where the latest iPhone that was released by Apple is titanium, and it's rumored that the other two major manufacturers, Samsung and Xiaomi, are also going titanium phones. It is a prized metal. It's lightweight, it's strong, super strong, it's corrosion resistant, it's got some other ideal properties for various applications. So from everything from the highest value applications or the most stringent applications like in a fighter jet, through to the applications in consumer electronics where you need stringent surface quality and surface finishes, This is a metal which, even without us bringing forward sustainable and lower cost titanium metal supply, is increasingly being looked at as a metal to incorporate into products going forward into the future. The problem, though, here is that titanium metal manufacturing is really centered around China and Russia, and this is a common thematic across a lot of critical minerals and metals. And so with the US having no strategic titanium metal sponge capacity, and China and Russia, especially China, increasing titanium metal capacity, this is a national security issue, especially because of its prevalence in defense and military products. So that is a key reason why we had started to focus on titanium. The other big reason is titanium is costly, and it's a complex process to make a titanium metal product. You don't just make titanium metal sponge, you need to take that through and you need to make a product. In this slide, I've expanded on how you get to an actual product. A customer like GKN or a customer like Panerai or a customer like Ford, they don't buy a titanium metal ingot or a titanium metal sponge or titanium metal powders. They buy a product, which they then take and then they incorporate in their products with some post-processing. So to get to those titanium metal products, in this case, to get to a watch case, the traditional supply chain had to go through the carbon intensive and environmentally intensive Kroll process, which is those first two process steps there. So through chlorination and then through the reduction and distillation into sponge. From there, you have to make these big 6 to 11 ton ingots. From those ingots, you need to break those down into titanium metal billets. From those billets, you need to roll them and machine them into bar. And then from those bars, you need to then slice them and then continue to machine them into watch cases. And this is the reason that titanium metal products are not seen as much everywhere around in common products, is because that supply chain is complex and that supply chain leads to very high cost titanium metal products. So that is another reason why we've focused in on the titanium metal supply chain and upending it, because we believe we can completely cut down on this waste and this complexity and this cost in the titanium supply chain. The other reason that is a big focus for us on titanium metal production is that today it's one of the most environmentally difficult or challenging metals to make. From a carbon perspective, it's far higher than even, say, something like aluminium, which is considered a very carbon intensive metal. And then from a circularity or recyclability perspective, it is not 100% circular today. There is some titanium metal that can be recycled back into the manufacturing of an ingot, but there is a lot of loss. There is a lot of downcycling into the steel industry, where titanium metal chips and shavings, like what you see in the picture there, are just sent into the steel industry and melted with steel as a microalloying element. So this is another reason, especially with groups that are consumer facing, like consumer electronics, like bicycles, like automotive, where they want to see more recycled products, they want to see lower carbon products. This is a challenge for them if they want to use more titanium metal. And that's why, again, we see a big opportunity to upend this supply chain and bring that sustainability to the titanium metal supply chain. And if we can do all this and lower the cost, change that complexity, bring that complexity down, or eliminate that complexity and lower the cost of titanium metal products, we think we can capture much larger markets. Today, the titanium metal market is relatively small compared to its counterparts, aluminium and stainless steel. If we lower that cost of a titanium metal product, if we make that titanium metal product even more carbon neutral and more circular than, say, stainless steel and aluminium, then we have huge markets that we can penetrate. And we're already seeing that with some of the products and some of the work that we're doing with the partners that we've announced to date. So our solution is primarily focused around our proprietary technologies. This allows us to convert titanium minerals or titanium scrap at low cost back into high performance titanium metal products. The technology was developed, as a lot of you know, out of the University of Utah by Professor Zach Fong. It was funded by ARPA and EERE from within the Department of Energy. And most recently, it's won additional awards. So the R&D 100 award, I don't think there's any other ASX company out there which has got a technology which has won an R&D 100 award. This is the top 100 technologies yearly that are looked at, that are evaluated, that are awarded this prestigious award. This is, a lead into a Nobel Prize for the inventors of these different technologies. And then, of course, we've won the AFRL, the Air Force Research Laboratories Grand Challenge for titanium metal recycling earlier on in the year. And there's been some other awards as well that the technology has seen or secured, like the X-Tech Military Award historically. So this is technology that was funded by the Department of Energy to lower the cost of titanium metal, to make it more accessible for automotive supplies, for the automotive industry. But it is a technology which continues to win awards, and we are very and highly confident of additional awards and also US government grants that are coming our way for the scale up and the continued development of our business. So what this technology primarily allows us to do is really two things. We've got the hammer technology, which is a big core part of the business, which is the refining of titanium minerals or titanium scrap into high quality titanium metal powders. That we have talked about a lot, but we also have what we like to call our forging technologies, which is hydrogen sintering and phase transformation, which allows us to take those powders and through a traditional, very simple press and sintering approach, a powder metallurgy approach, take those products and convert them or press them into shapes and forms. So with GKN, with the US Army, with Lockheed Martin, we're simply just casting out and manufacturing titanium metal plate. With some of our other partners with groups in the consumer electronics sector, or with our partners like Panerai, we're looking at shapes that can be pressed, that can significantly reduce the cost of the titanium metal products that they buy. These two technologies go hand in hand together. Our powders can allow us to supply into spherical angular markets, but then our forging technologies allow us to take some of those powders, the angular powders, and make high quality titanium metal products, avoiding completely that complex, high cost supply chain that you saw before. So this is essentially how we change that supply chain, remove a lot of those steps, go through our refining technologies, making spherical angular powder. Additive manufacturing or 3D printing is one way we're going, and we are making 3D printed products today for customers, like for Ford, like for Panerai. We do make some 3D printed watch blanks, but we also can go through tradition and manufacture more traditional shapes, what we like to call near net shape mill type products. So bars with a hole in them, things like that. And we can get into any product that is currently being used today by industry. So we can go into the advanced, complex 3D printed products, all the way down to simple plate, like what we're doing with GKN, Lockheed, and the US Army. So it allows us to our technologies allow us to completely disrupt that complex supply chain that you saw earlier on in the presentation, allowing us to go directly and more cheaply and more sustainably into titanium metal products that can allow for our customers to have cheaper titanium metal products, increase the use of their titanium metal products, titanium in their products, and provide them the whole host of benefits that titanium and sustainable titanium would give to their products. This is an example of how our solution is put into practice in the luxury goods sector, in the watch, as a watch case example. That watch case that you can see on the far right, the final part, less than 30 grams, that is essentially what our customer eventually machines themselves and uses as a watch case to then assemble a watch. The same way that watch is made is the same way that a smartwatch is made, is the same way a smartphone is made. So this is an example that covers what we call in the industry enclosures. So enclosures, whether it's for consumer electronics or whether it's for luxury goods, luxury watches, or normal watches. This is how that supply chain, or this is how we can affect that supply chain. Traditionally, that watch would be manufactured from, on the left-hand side, that traditional plug. So that is just a round bar that's sliced, and then that's the round bar, that sliced puck, what we like to call, or blank. You then take, you put it in a CNC machine, and that is carved out into that final watch case. So before IperionX was there, our customer like Panerai would take that puck, approximately a little over 300 grams, and machine that into a final part which is less than 30 grams. So they would lose more than 90% of that puck as waste. And so they're buying 10 times, in this case, they're buying 13 times as much titanium as what they need in the final product. So that's a big reason why titanium metal products are very expensive. Titanium can't be melted and cast easily into products like that, like what you would see with stainless steel or what you would see with aluminium. This is how the titanium industry has to go through and make a lot of products like this. When we come in from our powders, we can make that traditional puck, but at the same cost, we can make that IPX donut puck, or we can make that ovoid puck that you see there. That ovoid puck doesn't cost us any more to make. We take our powder, we put it into a shape, whether it's a circle or whether it's that ovoid, it doesn't cost us any additional, anything different. And we can make that ovoid. That ovoid, as you see there, would bring that buy-to-fly ratio from 13:1 down to 7:1. So still there's some scrap generation, but it's half as much titanium metal that our customer needs to buy to make that end product. So we've just halved the cost of a titanium watch case for them. You're halving the cost of a titanium watch case, you're getting pretty much the same level as a stainless steel watch case. And again, I need to stress, the way you make that watch case is the same way you make a smartphone, same way you make a smartwatch. It's pretty much exactly the same. And so this is where we can get in with our powders, with our titanium metal technologies, and improve the titanium supply chain and lower the cost of titanium metal products for our customers, thereby increasing the use of titanium metal in the products that our customers are manufacturing. And this is without even dropping the cost of the refining of titanium metal. That bar today is about $80 to $100 a kilo. We could make that for far, far less than that. So without even dropping the cost per kilo of titanium metal, we can substantially improve on the cost of our customers' products and thereby increase that use of titanium metal, take market share from some of these other metals as well. So in addition to doing that, in addition to improving cost, we also substantially improve the supply chain, the sustainability of the supply chain of titanium metal. We can take and make titanium metal far more sustainable than aluminium and equivalent to stainless steel. And we believe we can even drive that even lower as we continue to scale up our business. And then in addition to that, we today manufacturing a 100% recycled titanium metal product. This is validated by UL. UL is used by all the major firms in the United States to validate their products as being 100% or 70% or whatever recycled. It is used by groups like Apple and Google and groups like that. And so we came in, we had it audited, and we did receive our UL validation for being a 100% recycled titanium metal product. So in addition to cost savings, we provide our customers with these sustainability benefits as well, which for some customers, actually for all customers, it's on the radar, but for some customers, it is paramount to get these sustainability benefits into their products as well. So today, we are very much focused on our scale up in Virginia. We do have our industrial pilot facility working at full speed. We continue to drive forward some critical R&D products to keep us ahead of the curve over the next 5 years, 10 years. This is in new alloys. This is in optimized processes for us to continue to drive the cost of titanium metal manufacturing down. But a big focus of us today is that build up of the Virginia facility, which is ongoing as we speak today. We also do have the Titan project. We don't talk about it as much, but it is permitted. It's fully permitted. We've had Japanese groups very interested in development of this and securing securing supply of critical minerals from this unique deposit. It's right in the middle of the US. Excellent fiscal regime to be operating in. And as you can see, within 3 years of us going from the first drill hole, we were able to receive permits for this, and that's because of the excellent work of my team on the ground. So we are hard at work in developing this integrated titanium supply chain. Big focus over the next 12 months will be in Virginia and continue to be on pilot production as we scale up Virginia before we have full production there on pilot production in Salt Lake City. But over the longer term, you will see that integration with Titan will happen with our metals production. And so as we grow, I would expect us to see additional locations in the United States for titanium metal manufacturing. And the Titan project will naturally come online to supply and be part of our integrated strategy here on titanium metal manufacturing. In the next few years, though, the focus, like I said, is on Virginia. This will be the start of that full integration of the supply chain. It commercializes. Even from next year, we are at a commercial scale of titanium metal production. We are in the final stages of detailed design from our side. The county is upfitting the building, going through the process as we speak. And we expect that next year we will be commissioning and starting to produce significantly increased quantities of titanium metal from these facilities, both in powder form and also in shapes, bars, 3D printed products as well out of this facility. And from this facility, we'll be supplying into some of our existing partners like Ford, like Panerai, like GKN, like the US Army. But we also see this as a facility which allows us to grow our production and continue to bring more partners on board. Because today, quite frankly, we've got too much demand for what we can supply into. We've got multiple different industries wanting to look at our titanium metal products just because of where the cost could be, but also because of where the sustainability benefits are. And we actually have to be pushing back some customers. We just can't take on everything in our current industrial pilot facilities, which we would like to take on. But with the build out of Virginia next year, we are able to slot in both groups that want to work with us to develop more titanium metal products in their products, more titanium metal applications in their products, but also groups that have just come out to us and want to buy our powders or want to buy simple shapes, forms, bar, wire, plate, things like that. So even from next year, we will be able to significantly scale our production. And I think you're going to see us continue to add very large, globally significant partners to our list of partnerships and customers that we have developed over the last year. So that's about for us. Securing these partners, continuing to build out these partners is a big value add for our business. We've already done that across the automotive, defense, luxury goods sector. Like I said, as we build out Virginia, we have some high targets, some key targets in key industries, which we are working with today, which we would also like to be able to bring forward and secure as customers, which we're working on prototypes and things like that as we speak. And this includes in the green hydrogen and consumer electronics applications. But already with what we've done, we've been able to secure some excellent partners that are part of our growth, that help us grow, that are going to be cornerstone customers for us in 2024, 25, and as we continue to grow. And I believe that we will be able to continue to secure more partners. The more titanium metal products we can make, the more we can showcase our sustainable and our low-cost approach to manufacturing titanium metal products, the more interest we have from industry and some of these larger partners who want to use titanium metal for its benefits and want to use our American-made, sustainable and low-cost titanium metal in their products. So with that, I'll hand it over for some questions.
Wonderful. Thanks for that, Taso. How does the current geopolitical climate and the concentration of TI products in Russia, China benefit funding support for the business?
So that's a good question. So like we saw with the Air Force Research Labs challenge, the government has become more acutely aware of the issues with the titanium supply chain. So since the breakout of war with Ukraine and Russia, and even before then, but really with that breakout of war between Ukraine and Russia, we saw an increase or heightened level of interest in the titanium supply chain, because the titanium supply chain was shocked by that. A lot of Boeing and Airbus products were coming from Russian-made titanium metal products. So since then, we've seen multiple legislation passed by the US government focused on reshoring critical metal supply chains that were impacted by the geopolitical tensions. And so we're starting to see a lot of interest from DoD in particular in reshoring these supply chains. There's the Defense Production Act Title III program, which we are highly confident of receiving a grant from, which will help towards the build-out, the initial phase build-out of our titanium metal production facility. But there's additional funding opportunities available from the government. Recently, there was a request for information from DoD's IBAS segment, which was looking at reshoring a sustainable, integrated mineral to metal supply chain for titanium metal. And the way it was written seemed to be targeted very much towards us. Talked about looking at technologies which would improve the efficiency of production and move away from the traditional crow sponge process to manufacture titanium metal products. So in short, we've got multiple funding opportunities that are coming at us from the US government. We see a lot of potential. We are highly confident on a lot of funding in the short, medium, and long term for the scale up of our business, and it's because of those geopolitical tensions that it's come around. So we see a lot of opportunities there. I was only in DC 3 weeks ago, and there was a significant interest in what we're doing. And our team was just at a major military convention in DC just last night, and there's a lot of interest in what we are doing and how we can reshore a US source of titanium metal.
Thank you, Taso. You actually answered the next question. So next one is, so how would you say that industry is looking at the importance of not only cost and provenance, but also sustainability when looking at titanium?
So I think even when you look at something like the DoD, they do bring up that sustainable manufacturing because it is part and parcel of the administration's and the US government's push towards more sustainable manufacturing in general. But it's definitely provenance is a key thematic there from a defense perspective. But when you tip over to the other side and go towards consumer electronics, you go towards automotive, you go towards other mobility applications like bicycles, where the product will touch a consumer. That's where you're seeing a lot of interest in bringing forth sustainable titanium metal production. So we've seen a lot of interest in the reduction of carbon emissions, but there's a lot of interest in that circular supply chain. The circular supply chain seems to be a way where every company, it's an easy win for them. And it makes a lot of sense to bring in recycled circular products into their products, or bring in recycled titanium metal into their products. So definitely across the board, you're seeing a focus on sustainability, but definitely when the end product is touching the consumer, whether it's a watch case or when it's a smartphone, you're seeing a lot of interest in sustainable products, and us being the only potential source of sustainable titanium metal out there benefits us immensely.
Thank you, Taso. Jumping around a bit here. So the company recently announced the test work agreement with the US Army. When are we likely to get the results of this?
So we're starting that work with the US Army now. We were actually with some of their reps over the last few days. I'm currently in Perth, while my team was in DC. That test work, that is ballistic plate. So there's quite a bit of testing that goes on there. There's quite a bit of analysis that goes on there. It's a bit out of our hands once they do the ballistic testing, but I would expect to see, second quarter next year, the results of a lot of that ballistic testing. That is very important for us to get done, just to show, like we've shown in other industries, like in automotive, like in bicycles, like in luxury goods, that are titanium metal is equivalent to existing titanium metal products out there. It's important for the military to just get that done, shoot it, prove that it performs just as good or potentially a little bit better than existing titanium metal products that they've shot, and then we essentially get qualified into that supply chain, and then move from there into looking at being incorporated on things like the M1 Abrams tank.
Thank you. And as you mentioned in the presentation, so we've secured some leading global brands as customers and partners. So how are we currently selling or reaching out to these potential customers, or are they coming to us?
So it's a good question. Initially, there was a lot of us marketing ourselves to them, and this goes back from 2 years ago. So these are not relationships where you just walk in the door and you walk out with a signed partnership. These are relationships which have been built over a significant amount of time. Depending on the partner, it can take anywhere from 6 months to, say, something like 4 to 18 months. We go in there, we talk about our product, they do their due diligence on the technology, they involve their R&D teams. We then get into supplying some prototype products for them. They test them, they break them, they test the quality of the finished product from them. And then we get into the partnerships and how we move forward. That's how it went with Panerai. That's how it's going with Ford, where we're in the final throes of our finishing study, and we will most likely start seeing titanium metal products in their vehicles from end of next year. This is not just a straightforward get in there and walk out with an agreement. This is partnerships that are developed over time. So initially, it was a lot of top-down work from us, going in at the senior levels and being able to develop and educate some of the senior management and senior teams that wanted to use our titanium metal products in their applications. But as we've grown and as we've signed strategic partners, as we've gotten out there and built our brand within the US government, within the military complex, with some of our partners already, we're seeing customers now come to us. We've got actual product in the market, so and people like it, and it performs. I would say in some cases it performs better than what existing titanium metal products out there perform like. So we're starting to see, and I think we will continue to increase to see, especially as we scale up our production in Virginia from next year, we will continue to see, I think, customers come to us. There is some key customers that we continue to prototype with, or potential target customers that we prototype with, that we would hopefully like to secure over the next 6 months. And I think with those customers as well, it's just going to be a snowball. So it started off harder. I hate to say it's gotten easier, but it has gotten less challenging. It's gotten a lot easier. We walk into a group, we walk into a company, and we say, hey, that stainless steel product can be made titanium. It can be equivalent or slightly lower cost, and you get these sustainability benefits. It's usually like, really, is that even possible? And now, with product already being out there, with us already having a name out there, it's becoming a lot easier. So it's quite enjoyable as well. There's so many, but like I said in the presentation, there's so many industries and so many partners that we just have had to delay until our Virginia facility is up and running, that I think as we scale up, we will even a decade into building this company, I think we will still have new customers come to us. There's just so many opportunities to be using sustainable titanium metal in products.
Thank you, Taso. So next one. So when will the hammer process be at full commercial scale, and what is the cost to get it there?
So, I would consider, and looking at some of the markets out there, I consider from next year we're at commercial scale with the Virginia phase 1, what we were calling TDF of our Virginia facilities, up and running from next year. That is already commercial scale. If you consider how much plate is sent into some applications, we are seeing from the test work we did, the main part of our titanium metal manufacturing process is the hammer process. The hammer process is done within a specific furnace that's really an off-the-shelf furnace that we've already had manufactured, and we've been running hot test runs in it. It was manufactured in the Netherlands. From those initial tests, we're seeing what could be significantly improved numbers from what we had put out to the market before on the production of titanium metal out of just that existing furnace. So I'd consider that initial $20-odd million build in Virginia that we're undertaking as we speak is already commercial scale. It gets us into more products being sold into the market, and from there we can easily then, in a modular way, expand our production and continue to increase towards 1,000 and even more metric tons per annum of titanium metal production. So from next year we are commercial, and we're really changing and revolutionizing the titanium metal industry.
Thank you, Taso. So you answered the next question, but just further to that then. So what is the current status of your supply of scrap, and can the production be scaled up or expanded faster if you get demand?
So from a scrap perspective, that's sort of two questions in one. From a scrap perspective, there's plenty of scrap out there. We announced with the LG, we announced with DevTech, the supply of titanium metal scrap. We've got multiple different groups outside of there as well, where we're sourcing scrap and then using our ELG or working with our ELG partners to clean that scrap and get it ready, clean it of its oils and machining fluids to get it ready to go into our process. So I see no issue with scrap in the sort of next year, 2 years, as we head towards 1,000 tons per annum. As we head towards 10,000 tons per annum, that's when we need to start thinking about backward integration, 10, 20,000 tons per annum. But in the next 1, 2, 3 years, we've got a good source of scrap that was traditionally being sold into the steel industry, which we're able to upcycle into titanium metal products. So I don't see any issues with scrap, and we've got great partners there. From a titanium demand perspective, we've got the demand there. It's just physically how quickly we can have a furnace built and then scale up that. We are taking a relatively low risk approach to the build out of and scale up of the technologies. We're starting at this initial phase. Let's get that initial phase up and running. Let's make sure that it's humming, it's going well. We're supplying more and more powders. We're signing more and more customers, because going from 40 kilograms a week to 3 tons a week is a big difference in how much customers, how much product we can supply out there. So let's get that going, and then from there, let's assess how quick we can go. There is a plan where we can move towards 1,000 tons per annum by 2026. That's a significant scale. But there could be an opportunity for us to even move faster and quicker than that. So higher production throughput and bring that forward maybe 6 months and move much faster. And that's really all dependent, not just on demand, but on a lot of this government funding that we see coming towards the titanium industry. So we are highly confident of a DPA Act Title III funding grant in the short term for that initial phase 1. But as I talked about, there's other funding opportunities that were announced, especially this recently by IBAS, which could help us really accelerate the development of our titanium scale up and take us to plus 1,000 tons per annum very, very quickly in a short space of time. So right now, I'm very focused on scaling up Virginia in that first phase, 2024, getting it going so that we can supply our existing customers with more product. We can bring in new customers into the fold. And then from there, as we head into 2025 and 2026, I think there's opportunities, and opportunities will present themselves to us both from customers and from government funding opportunities to scale that even quicker.
Thank you, Taso. Sorry, we've got a lot of questions coming through. So do you have competitors with access to the technology?
No, this technology is fully secured by us, IP and everything like that. We are very focused on, at the moment, because of our work with the Department of Defense, increasingly with the Department of Defense on cybersecurity and physical security protocols that we're putting in place for the Virginia facility and also for our own systems. And then we are very focused on our patent strategy and defending our patent strategy and making sure that we put in place safeguards there to make sure that there's no leakage of what we say are proprietary technologies. So not just our IP rights, but our trade secrets and our know-how as well. So we're lucky in that we've been able to secure one of the top patent attorneys as our strategic advisor. He's also a big investor in our company. And he's been excellent working with my chief legal officer and us as an executive team in putting in place the right strategy. So we continue to build on our patents, and there's a whole raft of additional R&D optimization opportunities that we're working on as we speak that are also patentable or trade secrets. And we keep that under tight lock and key. And we've put in place, and we continue to improve on and put in place, the right sort of cybersecurity and physical security protocols, because nobody else can do this. And this is a huge competitive strategic advantage for us in that we've got the Titan project, it's fully permitted, but we've got these proprietary technologies which can take the scrap or the minerals and provide and build out this unique, low cost, not complex sustainable titanium metal supply chain. And so we're very, very focused and have been very focused on that.
Thanks, Taso. Jumping around a bit again. So could you comment on the pros and cons of the hammer/GSD process versus the automation process in the production of titanium?
Versus the atomization process so atomization is used for just the manufacturing of spherical titanium metal powders. That's the traditional. There's different approaches to atomization. There's gas atomization, there's plasma atomization. Gas takes a bar and you put it through the gas atomizer and create spherical particles. Plasma atomization, which is done by, say, APNC, which is part of GE, or 6K, is a wire that's then goes through a plasma torch and creates spherical titanium metal particles. So they all require they all right at the end step of that titanium supply chain. So they require minerals to be made into sponge, to be mixed with some scrap, to be made into an ingot, to then be made into bars, and wire to then be atomized. So our process eliminates all of that. So our hammer process allows us to use, we call it the GSD process, which is essentially granulation, sintering, and hammer, which allows us to take scrap, crush it. If we just crush it and use hammer on it, it's angular powders. But if we crush it and use a thermomechanical process to make spherical particles, we then deoxygenate those spherical particles and have purified titanium metal spherical particles that compete with, gas or plasma atomized powders. The pros of our process are immense because we avoid that complex supply chain. It is a non-melt process, much lower energy, much lower carbon intensity. much lower cost. We avoid having to buy a bar or a wire, which, bars $80 a kilo, wires, if you want to have American-made wire, it's over $100 a kilo. We avoid all that process. We go directly from scrap to powders, minerals to powders, to spherical powders. The only cons I would see is that the industry currently has used gas or plasma atomized powders. So there has been questions on, do your powders perform to the same level as these powders? And that's where, even with a group like GKN, who has got a 3D printing division, we've been, working with them on them using also our 3D printed products. With Lockheed Martin, the same sort of thing. With Panerai or Canyon, the basketball brand, we use our 3D printed spherical powders to make 3D printed products, and it performs just as good as GE powder that's out there in the market, which is considered the best. So I would say limited cons, really the one being that it's just an unknown product. So we're just qualifying that product into some applications, and we've already done that. And we have products that are made from our spherical powders already out in the market. But the pros are that, you have a process which avoids the melting, the manufacturing of ingot, and that complex supply chain. So it just makes it a lot easier to get to that spherical particle, which some of these players want. It's a good question, though.
Wonderful. Okay, next question. So do you know where Apple is sourcing their titanium for their new iPhones?
I can't comment. So let's move to the next question, please.
Okay. How and when would your Titan project in Tennessee fit into the longer term strategy of the company?
So that's a good question as well. Actually, this is one of those things we get a lot of questions why we even have the Titan project from some of our American investors that we've presented to. And in the end, we're able to show, and they agree that it is important for the future. But exactly when that future is, when we backward integrate Titan into our portfolio and backward integrate and manufacture titanium metal products, is yet to be known. And it really depends on how fast we scale over the next few years. There could be a scenario where we need Titan in 2027. Because we're going over 10,000 tons per annum of titanium metal production. I definitely see it before 2030 that we need to integrate Titan into titanium metal production, but it's still definitely up in the air as to exactly which date it is. And that's why it was so important for us to progress Titan, have it fully permitted, and have it ready to go for whenever we need it to get going. Because I don't want to be in a position like the automakers were, where all of a sudden they said, okay, we're moving to electric vehicles and we don't have the lithium supply. All right, let's bring on a lithium mine. It takes a year, it takes another few years for lithium chemical refining capacity, and then you're stuck. So I don't want to be in that position. We have the Titan project there ready. As soon as we're starting to see that we are getting restricted on scrap, say we're moving to 10,000 tons quickly, we can put in place a plan to develop Titan very quickly and go from there. The only caveat to developing it later is that we have got a lot of interest in the Titan project because the titanium metals are used by other industries, are highly prized by other countries that are dependent on it as well, in particular Japan. So we did announce we had a couple of Japanese groups that have come to site, multiple Japanese groups. We did just have one Japanese group complete close to a 6-ton bulk sample, and they're very interested in the titanium and rare earths from the Titan project. And so there is a scenario which could play out where we do have a joint venture partner on the Titan project in fairly short order. That would mean that the Titan project goes into operation sooner than what we need it. We eventually still retain the right to backward integrate it, but it does go into operation sooner than what we needed, because there is a strategic want for these type of American titanium and rare earth minerals to be developed. From a valuation perspective, I see the Titan project as providing a put option on our business as well. When investors are looking and assessing us, that Titan project has value even if it's more difficult for people to sometimes put value on the technology side of our business, which has got this huge upside. Sometimes it's unbelievable how big this could be. You can always look at the Titan project and go, well, that has a significant amount of value there as a base for where our company is at. So Titan project is very important to us. That's why we permitted it. It's from a strategic perspective for backward integration. It's going, in my mind, it could be 2, 3, 5 years out, but definitely before 2030 in my mind. But we shouldn't really talk it down, because it has got rare earths, it has got valuable titanium minerals in there, and we have got a lot of strategic interest in the project as we speak.
Thank you, Taso. We're running out of time, so I've just got 2 more. So is IPX looking to expand internationally outside of the US?
Good question. Again, it's a question that comes up with some customers. It's a question that comes up multiple times. Right now, in our short-term strategy, no. Our short-term strategy is get Virginia up and running, and then start to scale Virginia even higher. So that's next year and potentially into 2025 as well. But once we have Virginia humming, there is some customers and some customers where we see opportunities to expand potentially internationally, and this is really focused maybe on customers which are allies with the US as well, because we've got to be very careful about where we will put a plant in the end. But I do see opportunities. Probably firstly is more scale within the US, closer to some of the supply bases in the US. Like there's a lot of, Lockheed Martin has their major F-35 production down in Texas, for instance, a lot of scrap generation there as well. But there could be an opportunity to expand into Europe in fairly short order, in the right location, expand into Japan or South Korea in fairly short order. But really, that's more of a medium-term objective for us. We think about it, we assess it, but the focus right now for our business is focus on Virginia, get that right, get that scaled. This time next year, I would like to sit here and be doing 3 tons a week of titanium metal products, and that allows us for huge additional customers that we can secure. So in the medium and long term, yes, there most likely will be in allied countries opportunities for expansion. There's also opportunities for mobile units, which we've assessed, especially for the military, where you can imagine it's at the front line, it's in a couple of containers, you're able to take scrap that's coming off the battlefield and recycle it. But from a facility perspective, not in the short term, not in the next year, but I think as we look towards 25, 26, 27, there could be opportunities where we expand internationally.
Okay, Taso, so just finally, and to recap, maybe if you could just let the webinar attendees know what they should be looking forward to over the next 3 to 6 months.
Absolutely. So when we were here last, we talked about scrap, we talked about customers, we talked about permitting. We've hit a lot of our targets, and we continue to hit a lot of our targets. I would say we continue to look at additional customers, really be on the lookout for that. Over the next, say, 6 months, we're building out Virginia. So there's some really exciting progress that we're going to be able to have there. And there's some really exciting developments that we're working on in the background that I can't wait to share with everyone around not just the manufacturing of titanium metal powders, but manufacturing those into products at prototype and small production scale. So very excited on that scale up in Virginia and getting to that commercial scale next year. And then from the Titan side, I think there is still some exciting opportunities around those joint venture, those strategic partners that are coming to us. And then above that all, we are, like one of the questions asked, we are really lucky that we're at the center of this reshoring titanium metal, sustainable titanium metal production in the US. And there's a lot of we are highly confident on government funding across there, and the government has not funded yet any particular player for reshoring of titanium metal refining, and we feel highly confident that we could be one of the first players in industry to be funded to develop a advanced American low-cost titanium metal supply chain. And I think that in and of itself will be a major milestone as well for us. And that would be the first of what I would say would be many funding opportunities, that non-dilutive funding opportunities that can come from the government with its focus on reshoring manufacturing supply chains in America. So a lot of exciting developments to have. We've hit a lot of our targets over this year. We've still got a little bit of this year left, and I think we're going to hit a few more targets. But we've got an exciting 6 and 12 months ahead of us, which will see us go into commercial production in Virginia and really start changing the game for titanium metal products for the good of a lot of industries.
Wonderful. Well, that's all we've got time for today. I want to thank you all for joining us for the IperionX Limited Investor Webinar. If we have missed any of your questions, please feel free to reach out by the contact details on the bottom of our ASX releases. But we look forward to hosting you again next time.
Thanks, everyone.